Germany built a mining machine so large that from the ground, it barely looks like a machine at all. At Lichterfeld in eastern Germany, the F60 stretches 502 meters from end to end, a steel structure longer than many city blocks. It is nicknamed the Lying Eiffel Tower because instead of rising into the sky, it lies across the landscape like a horizontal landmark. But this was not a monument. It was built to move. The F60 was not a truck, not a crane, and not a normal excavator. It was a bridge-like conveyor machine designed to crawl through an open-cast lignite mine, carrying overburden away as the pit advanced. Years of planning, engineering, and construction produced a machine meant to serve for a long industrial life. It entered operation in 1991. By 1992, it had stopped. So why build something this enormous if history was about to make it obsolete? In an open-cast lignite mine, the coal is not reached through deep tunnels. It is reached by opening the ground from above, layer by layer, until the brown coal seam is exposed. The problem is that the useful material is buried under enormous amounts of useless material. Miners call this overburden. It can be soil, sand, clay, gravel, or rock. It has no value in the power station, but it still has to be moved before a single ton of lignite can be taken out. In a small operation, that sounds simple. Dig it up, load it into trucks, drive it somewhere else and dump it. But in a lignite pit, the scale breaks that logic. The mine is not moving a few piles of dirt, it is continuously stripping away a landscape. Every truck would need a driver, fuel, roads strong enough to carry it, space to turn around, and time to return empty. Then the roads would have to be rebuilt as the pit changed shape. The deeper and wider the mine became, the longer every journey became. More trucks would be needed just to keep up, and each one would add more traffic, more maintenance, and more delays. The mine needed the material to flow, not travel in separate trips. That is where a machine like the F60 made sense. It was built as a moving bridge across the working area of the mine, linking the place where overburden was being dug to the place where it could be dumped or transferred onward. Instead of sending truck after truck down into the pit, conveyors could carry the material continuously across the gap. This is the industrial shortcut hidden inside the machine's strange shape. The F60 was not oversized for the sake of it. Its length allowed it to span part of the mine itself, crossing terrain that ordinary vehicles would have to crawl around. So the machine's size was a direct answer to the mining problem. Before lignite could feed power plants, the land above it had to be removed at a speed only a continuous system could match. Lusatian became one of the industrial heartlands of East German energy because it had something the country could rely on: enormous deposits of lignite, close enough to the surface to be mined in open pits. This was not high-grade coal. Lignite is brown, soft, wet, and less efficient than hard coal. But East Germany had it in huge quantities, and for a planned economy with limited access to imported fuels, that mattered more than almost anything else. The mines of Lusatian fed power stations, briquette factories, chemical plants, and heavy industry across the country. By the second half of the 20th century, the region was no longer just a mining district, it was a connected energy system. Excavators cut into the landscape, conveyor belts carried material through the pits, overburden bridges shifted the waste. Power plants burned the coal almost as quickly as the mines could deliver it. The F60 belonged to that system, not as a curiosity, but as one of its largest moving parts. The machines were developed by TAKRAF, the state-owned heavy engineering organisation based in Lusatian. TAKRAF was responsible for some of the biggest mining equipment in the Eastern Bloc, and the F60 series was one of its most ambitious answers to the scale of Lusatian lignite extraction. The name came from its designed cutting height of 60 metres, but the feature people remember is the length. At roughly 500 metres from end to end, an F60 was longer than many skyscrapers at all. It was often described as a lying Eiffel Tower because that was the easiest way to make its size understandable. 5 of these conveyor bridges were built. Each one was designed for the same basic purpose: remove overburden continuously at a scale that matched the hunger of the coal economy. The machine at Lichterfeld-Schacksdorf was the 5th and final F60. It represented the last step in a line of machines built for a state that expected lignite mining to continue for decades. When it entered service, it was not meant to be a monument. It was meant to be a working instrument in one of Europe's largest coal landscapes. That is what makes its short operating life so striking. It was born from a system built for permanence, then arrived just as that system was about to collapse. The F60 at Lichterfeld-Schacksdorf was not just big by mining standards, it was approximately 502 meters long, up to around 80 meters high, and weighed about 13,600 metric tons. That length is the number that makes people stop. Half a kilometer of steel, rails, belts, cables, walkways, motors, and support frames stretched across the mine. If you stood at one end, the far end was not just distant, it was far enough away that the machine read less like a vehicle and more like a piece of infrastructure. This is why the nickname the Lying Eiffel Tower stuck. The Eiffel Tower is the familiar image of a tall iron landmark. The F60 gave a similar impression, but turned sideways across the landscape. It was not a perfect comparison in engineering terms, but visually it worked. A giant steel lattice, open to the air, long enough to become a horizon line. And the F60 was not one machine in the simple sense. It was a truss bridge, a conveyor system, a rail-mounted machine, and an industrial platform at the same time. The truss structure gave it the strength to span huge distances across the open pit. The conveyor belts moved overburden away from the working face continuously. The rail system allowed the whole bridge to shift as the mine advanced. The platforms and walkways gave workers access to machinery spread across hundreds of meters. Ordinary construction equipment is measured in meters. A large excavator, a crane or a haul truck can look enormous on a building site, but the F60 belonged to a different category. It was built to dominate an entire mining landscape, not a single work zone. Its height mattered too. At up to 80 meters, parts of the structure rose higher than many apartment blocks. From the ground, the steel framework towered above the pit, while its long body stretched across it like an industrial bridge that had somehow become mobile. The mass completed the picture. 13,600 metric tons meant the machine was not merely long and tall. It was a moving steel landmark, heavy enough that every rail, support and foundation beneath it had to be part of the design. That scale was the point. The F60 existed because Lusatian mining was not trying to remove overburden in batches. It was trying to move the earth continuously, day after day, at the pace of an energy system built around lignite. The F60 worked as the middle piece in a much larger mining system. At the active edge of the open pit, bucket chain excavators cut into the overburden. That overburden was the soil, sand, clay and rock sitting above the lignite seam. The excavators did not load it into trucks, they dug continuously and fed the material straight onto conveyor belts. From there, the earth entered the F60's conveyor network. This is the part that makes the machine make sense. The F60 was not built just to dig, it was built to move what had already been dug across a vast open pit without stopping for loading cycles, traffic routes or return trips. The bridge spanned the mine from the excavation side toward the dumping side. As material arrived on its belts, the conveyor system carried it along the length of the structure. Instead of hauling the overburden away from the pit, the F60 transferred it across the pit and deposited it behind the active mining area. That meant the mine could work in a moving sequence. At the front, machines stripped away the layers covering the coal. In the middle, the F60 carried that stripped material over the operating area. Behind the working face, the same earth was placed back into the mined-out section of the pit. The scale of the process was enormous. The F60 system could handle roughly 29,000 cubic meters of overburden per hour. In mass terms, that was about 50,000 tons every hour, depending on the material. To move that amount with trucks would have required a huge fleet operating almost non-stop. Every truck would need to be loaded, driven, emptied, turned around and sent back through the mine. Roads would have to be maintained, fuel would be burned on every trip, drivers and dispatch systems would be needed to keep the fleet moving safely. The F60 replaced much of that movement with a continuous flow. Its size was therefore not a vanity project. The length allowed the machine to bridge the gap between where material was removed and where it needed to be dumped. The belts turned a complicated transport problem into a direct industrial process. The rails allowed the whole structure to shift as the mining front advanced. So when people describe it as one of the largest moving machines ever built, that is only half the story. Its real purpose was efficiency at a scale where ordinary transport methods became the bottleneck. The F60 was a moving bridge for Earth, designed to keep the mine advancing while thousands of tons of overburden flowed across it every few minutes. The rails are what made the F60 more than a giant conveyor belt. From a distance, it looked like a fixed steel bridge laid across the mine. But the entire structure sat on rail-running bogies spread across multiple tracks beneath its supports. Those bogies carried the weight and allowed the machine to shift sideways with the working face instead of staying in one permanent position. This mobility was essential because the mine itself was always moving. Each time the excavators cut farther into the overburden, the point where material entered the system changed. The dumping side also changed as the mined out ground behind the operation was filled back in. If the bridge could not follow that movement, the whole continuous process would break. The F60 moved at about 13 meters per minute. That is walking pace for a person, but for a structure roughly 500 meters long and thousands of tons in weight, it was extraordinary. Every movement had to keep the conveyor lines, rail tracks, and transfer points in alignment. Just listen to the kind of machinery this movement depended on. Its operating range inside the mine was roughly 6 kilometers. Within that zone, the bridge did not roam freely like a vehicle. It advanced along planned rail paths, coordinated with the excavators feeding it and the dumping equipment receiving material on the other side. That coordination mattered because even a small misalignment could interrupt the flow of overburden. The belts had to meet at the correct points. The supports had to stay balanced on their tracks. The operators had to move the machine without twisting a structure longer than many city blocks. So the F60 was not fast, and it was not flexible in the way a truck is flexible. Its strength was controlled movement at enormous scale. It could shift just enough at the right time to keep a vast open pit mine working as a single connected system. The Lichterfeld F60 was built on a timeline that made perfect engineering sense until history moved faster than the mine. Construction began in 1988, when this part of Germany was still East Germany and lignite was still a central pillar of its energy system. The country needed enormous machines because its power stations needed enormous quantities of brown coal. In that world, ordering a 500-meter overburden conveyor bridge was not strange. It was infrastructure for an economy designed around continuous extraction. But the machine was not finished in that world. The build continued through 1989 as protests spread through East Germany. It continued through the fall of the Berlin Wall. It continued through negotiations, currency union, and the political process that ended with German reunification in 1990. By the time the F60 was ready, the state that had ordered it no longer existed. This is the timing twist at the center of the whole story. The machine began operation at the Klettwitz-Nord mine in March 1991, after reunification had already changed the rules around it. The mine had not physically disappeared, the coal was still in the ground, the rails, excavators, conveyors and power stations were still there, but the economic landscape had shifted almost overnight. East German industry was being evaluated under a new system with new costs, new environmental pressures, new ownership structures and new expectations about what could survive. A machine like the F60 could not adapt to that kind of change quickly. It had been planned years earlier, designed for a specific mine, built from steel, motors, rails and conveyor systems that all assumed long-term operation. Mega projects move slowly because everything about them is heavy. The contracts, the components, the transport, the installation, the testing. Politics did not move slowly in those years. A country vanished, markets opened, energy policy changed direction. Mines that once looked necessary could suddenly look uneconomic. So when the Lichterfeld F60 started work, it was not entering the stable future it had been designed for. It was entering a transition period where every large industrial asset in the former East Germany was being questioned. That is what makes its short career so unusual. The F-60 was not a technical failure. It was built, delivered and put into service. The problem was that it arrived in a world that had changed while it was being assembled. The Lichterfeld F-60 went into service in March 1991. By June 1992, its working life was effectively over. That means this 500-metre machine, built to dominate an open cast mine for decades, operated for only about 13 to 15 months. Not because it collapsed, not because the design failed, not because the bridge could not do the job. Available accounts point to economic reasons. The industrial system around it no longer needed it badly enough to justify keeping it running. At full capacity, machines of this type were built to remove overburden on a staggering scale, clearing the layers of earth above lignite so bucket wheel excavators could reach the coal. The F-60 was part of a chain. It only made sense if the mine, the coal demand, the power generation and the briquette production all made sense together. After reunification, that chain started breaking. The Klettwitz-Nord mine had been intended to supply facilities in the region, including power generation and briquette factories, but the early 1990s brought restructuring across the former East German lignite industry. Plants were assessed for cost, efficiency, pollution and competitiveness in a unified German economy. Some facilities were modernised, some were reduced and others were closed or no longer had the same role. For a mine, that matters immediately. A giant overburden bridge does not produce coal by itself. It prepares the ground for coal extraction, and that only pays if there is a stable buyer for the coal. If the customers shrink, close or become uneconomic, the mine loses its reason to keep expanding. So the F-60 became a victim of timing and scale. It was too specialised to be casually moved into some new job. It was too large to operate cheaply as a temporary tool. And it was tied to a mining plan that had been created for an energy economy that was disappearing. This is the central tragedy of the machine. The engineering worked, the steel structure stood, the conveyors could move immense quantities of material, the bridge was capable of shifting tens of thousands of tons per hour. But capability is not the same as purpose. In 1992, the Lichterfeld F-60 was taken out of service, not as a ruined machine, but as an obsolete answer to a question the economy was no longer asking. Once the F-60 stopped working, the normal plan was simple: dismantle it. For a machine this specialised, there was no easy backup career. It was not a crane that could be sent to a port or a conveyor that could be bolted into a factory. It was a half-kilometre mining bridge, designed around one landscape, one mining method and one industrial system. And leaving it where it stood created its own problem. The mine was changing. The land around it had to be secured, reshaped and eventually flooded as part of reclamation. A steel structure longer than many city blocks could not just be abandoned in the middle of that process. So for a time, the most realistic future for the F-60 was cutting torches, scrap metal and disappearance. That would have been a familiar ending. Across mining regions, enormous machines often vanish when the economics around them collapse. Their parts are sold, their steel is recycled, and after a few years only photographs prove they existed. But the Lichterfeld Bridge was different in one important way. Its uselessness as a working machine made its uniqueness easier to see. There were other F-60 bridges, but this one had become a complete, visible monument to the scale of Lusatian lignite mining at the exact moment that world was being transformed. Local authorities, preservationists and regional planners began to treat it less as obsolete equipment and more as industrial heritage. The answer required an engineering solution almost as strange as the machine itself. The bridge had to be saved from the future lake and moved to safer ground, without pretending it could ever return to ordinary service. So instead of being reduced to scrap, the F-60 was shifted to higher ground and prepared for a second life. The machine built to strip earth away would become something people climbed, photographed and remembered. In May 2002, the preserved F-60 opened to the public as the F-60 Visitor Mine at Lichterfeld Schacksdorf in Brandenburg. What had been a working piece of mining infrastructure became a destination. Visitors could now walk through parts of the steel structure, follow guided tours along its elevated routes, and climb to viewing platforms that turned the former mine into a panorama. From up there, the scale becomes physical. The bridge is not just long on paper, it takes time to cross. It fills the horizon. It makes people measure industrial history with their own legs. The site also became a place for interpretation. Exhibits and museum material explain how lignite mining shaped Lusatia, how machines like this moved overburden, and how entire landscapes were reorganized around energy production. Around the bridge, the former mining area has continued to change, with reclamation, water, and new uses replacing the old open pit. That is what makes the present-day image so strange. The F-60 was built to erase landscapes layer by layer. Today it stands inside a landscape that has survived, changed, and absorbed it. The machine that once made ground disappear is now part of what people come to see. It has also become a stage. Concerts, events, night tours, and light installations use the bridge not as machinery but as architecture. Its latticework steel, once valued for strength and reach, now creates shadows, silhouettes, and viewpoints. And because it no longer moves, the story becomes easier to understand. There is no noise, no conveyor belt, no advancing wall of equipment, just the giant frame fixed in place, showing the size of the system that built it. The Lichterfeld F-60 worked for only 15 months, but in stillness it has lasted far longer, preserving the memory of a vanished industrial era in the form of one half-kilometre machine. The F-60 represents a paradox at the heart of modern engineering. It did what it was designed to do. It reached across an open pit, carried conveyor systems, and helped strip away overburden on a scale that smaller machines could not match. As a technical answer to a mining problem, it worked, but it arrived when the problem itself was being rewritten. After German reunification, East German industry faced new economic rules, new environmental standards, and new political priorities. Lignite mining did not vanish overnight, but the old system that had demanded machines like the F-60 was no longer secure. Entire industrial regions had to be reassessed, not just for what they could produce, but for what they cost to maintain, modernize, and justify. That is why the machine's short career matters. It was not retired because it was too small, too weak, or too primitive. It was retired because the assumptions behind it changed faster than the steel could wear out. Infrastructure often carries the confidence of the moment that built it. A bridge, a power station, a rail line, or a mining machine can look permanent because it is made from concrete and steel, but the reasons for building it can be far more fragile. The Lichterfeld F-60 is one of the clearest examples of that mismatch. A moving bridge built for an expanding industrial landscape became a fixed monument to a shrinking one. In the end, it did not fail as a machine. It was overtaken as an idea. A bridge learnt to move across the earth, and then history froze it in place. Today, the F-60 no longer crawls across a working pit. It stands at Lichterfeld as a visitor attraction, a steel walkway, and a preserved fragment of a mining system that once depended on constant motion. That is the strange ending to this machine's story. Germany built a 502-metre overburden conveyor bridge for decades of lignite work, and it operated for only about 15 months, not because it could not do the job, but because the world around the job changed. On the ground, it still looks impossible, a horizontal lattice of steel so long it earned the nickname the Lion Eiffel Tower. Once it moved Earth. Now people climb it, photograph it, and look out over a landscape reshaped by the industry it served. If you want more stories about machines that outlived the worlds they were built for, subscribe to Industrial Empire. Thank you for watching. Write a comment with the abandoned or preserved mega machine you think deserves a future episode.